For most of human history, we've searched the universe for life by asking a simple question. Is anyone alive out there? But that question may be wrong. Because life is fragile. Civilizations are fragile. Technology is not. If an intelligent species existed millions of years before us, their bodies would be gone. Their cities would be dust. Their planet might not even exist anymore. But their technology could still be there. We've spent decades searching for biology, oxygen in atmospheres, traces of water, chemical imbalances that hint at microbes. And that makes sense. Biology is where intelligence begins. But intelligence doesn't stay biological for long. Advanced civilizations consume energy. They build. They expand. And every act of technology leaves behind evidence. These traces are called technosignatures, physical proof that something, somewhere, once engineered the universe around it. This idea forces us to confront an uncomfortable truth. The universe is nearly 14 billion years old. Our galaxy alone holds hundreds of billions of stars. If intelligent life is even slightly common, then some civilizations should have had a head start of millions, maybe billions of years. So where are they? This question is known as the Great Filter. Either intelligent life rarely survives long enough to become advanced, or we've been looking for the wrong signs. Technosignatures give us a different way to look. The key insight is brutally simple. You cannot use energy without leaving a trace. No matter how advanced a civilization becomes, physics doesn't negotiate. Energy use always produces waste heat, always alters the environment, always leaves fingerprints that nature alone cannot explain. You don't need aliens to send messages. You just need to find what they changed. One of the most extreme examples is the Dyson sphere. Not a solid shell, but a vast swarm of structures orbiting a star, capturing its energy output. A civilization capable of this would harness the full power of its star, becoming what scientists call a Type II civilization. From a distance, such a star wouldn't look normal. It would appear dimmer than it should, yet glow strongly in infrared light. The star itself becomes the message. And some ideas go even further. There are theoretical structures known as stellar engines, machines capable of slowly moving entire stars using radiation pressure. Over millions of years, a civilization could reposition its star within the galaxy to ensure long-term survival. If astronomers ever observe a star drifting against the natural flow of the galaxy, it wouldn't be evolution. It would be intentional. But technology doesn't need to be massive to be permanent. An advanced civilization wouldn't need to travel the stars themselves. They would send machines. Self-replicating probes, often called von Neumann probes, could spread across the galaxy, copying themselves using local resources. One probe becomes many. Many become millions. In theory, a single civilization could explore the entire Milky Way in a fraction of its lifetime, which leads to a haunting question. If this is possible, why hasn't it already happened? Because of that question, scientists are now looking closer than ever before. Not just at distant stars, but at our own solar system. Searching for objects with strange orbits, unknown origins, behavior that doesn't match natural debris. Alien archaeology may not begin light years away. It may begin right here. This is also why unidentified phenomena are studied carefully, not as proof of aliens, but as anomalies. Most are explained. Some are misidentified. A few remain unresolved. Technosignature science doesn't ask what they are. It asks only one thing. Is this natural or engineered? The search itself has evolved. We no longer listen only for radio signals. We now search for laser emissions, artificial neutrino beams, and even unnatural gravitational wave patterns. Massive datasets are analyzed by artificial intelligence, because no human can see patterns at that scale. And instruments like the James Webb Space Telescope scan the universe in infrared, capable of detecting the thermal fingerprints of megastructures hidden across interstellar distances. We may have already seen technosignatures, and simply didn't recognize them yet. If we ever confirm one, it won't mean invasion. It won't mean contact. It will mean something quieter and far more profound. That intelligence survived long enough to reshape stars, that civilizations can endure, and that the universe has remembered others before us. In the end, the search for technosignatures isn't really about aliens. It's about legacy. What traces will we leave behind? Will our technology outlive us? Or will humanity fade without leaving a mark worth finding? Somewhere in the dark, the universe is keeping records. The question is whether our civilization will be one of them.